Okay, good morning, everyone. I'm Aditya Patil.
And I'm Prathamesh Kurunkar. We are here from the Comet company, and we are here to talk about building high-quality native mobile apps with Frappe and React Native. This is going to be a talk about our journey while building the Raven mobile app. And by no means we are experts in developing mobile apps. We are building a mobile app for the first time. So this is more of what to do and more of what not to do while building mobile apps. So yeah.
So this is our journey building Raven Mobile. So we are the Commit company. Apart from Raven, we have built a few other libraries that surround Frappe framework and Frappe ecosystem. So we basically build developer tooling around the Frappe ecosystem. And these are some of the libraries that we maintain. And for those who don't know, Raven is an open source work messaging tool. It runs on the same server as any other Frappe app, and it integrates seamlessly in the Frappe ecosystem. And we are active on more than 360 sites on Frappe Cloud right now. And since we started Raven, we have always had a PWA, and it works just fine. Like it has complete feature parity with our web app. So why do we even need a native app? So there are many challenges that we face with PWA. So like a lot of people don't even know how to install a PWA. So installing a native app is very easy. Like you search it on App Store and you just click install. But installing a PWA, it's not what everyone knows. The performance and user experience is also very different on a PWA. So the haptics, gestures, animations, they are a bit laggy. But on a native app, they run smoothly and seamlessly. And sharing. So a PWA is not a share target. So you can't share from one app to a PWA. But on a native app, if you set it as a share target, you can share from, for example, Twitter. You can share a tweet directly onto Raven. And on a native app directly interfaces with your device's capabilities like camera, microphone. And it also has like resource allocation, like CPU time, GPU time, which improve performance a lot. And also storage that can allow us for full offline capabilities. And push notifications. So on a PWA, push notifications, they work, but they are very rudimentary. So we can't show like a profile picture of who sent the message. Or we can't allow someone to do something directly from a notification. But if it's a native app, you can actually like kind of send a message directly from the notification. And also priority, PWA notifications are like very low priority notifications. So if there are a lot of PWA notifications, the operating system like iOS, they will like block notification. They'll consider it like spam. But on a native app, they are like priority notifications, and they always come on time. So that's why we build a mobile app. So here's how our app looks. This is our. So it is like a lot smoother and stuff. You can just move. So the tech stack we used. We are using React Native since our web app is built on React. So React Native was a lot familiar to us. And it later on helped us to make a lot of things in common. Then Expo brings a lot of stuff like it has developer tooling and a lot of libraries that help interface with native hardware. Like it has libraries for camera, like opening built-in document picker and stuff. And we are using Jotai for state management. We are using our libraries like Frappe React SDK, Frappe types. And SWR, it is part of our Frappe React SDK. We use it for caching data that we have fetched. And we are using native Wind for our UI. So we have faced a lot of challenges during this development. And these are the major challenges that we have faced. And we'll go through them one by one. So the first challenge was authentication and multi-tenancy. So since Raven is a multi-tenant app, since you are allowed to enter your own site URL, you'll have to enter your own site URL. So cookie-based authentication won't work for that, because for cookie-based authentication, you need to have a session ID and stuff, and for that you'll have to like whitelist the website URL, your Frappe server URL. That is just not possible, since we are allowing you to enter any URL. So cookie-based won't work. And obviously, API key and secret's a no-no. You should never expose your API key secret. So the only right option was to go with the OAuth Flow. So this is basically the general OAuth flow. What we are doing is just we are allowing the user to enter the site URL in the app, and then it based on that URL, we'll send a request, and from the Frappe server, we'll fetch the site info and the auth ID. That's the standard OAuth flow. And once we receive the access token, we are using the exchange authorization token method here. Once we receive the access token, we store it in our client app in secure store with the site name. So what about logging out? Like, we have logged in, but what about logging out? So we need to revoke token on site when we are fetching new tokens. So we were not doing that before. So this is, in this meme, this is basically the reaction of Nikhil, our leader. So what we were doing is that we were logging in whenever and creating these access tokens, but when we were logging out or refreshing the token, we were not deleting, we were deleting the tokens from our front end, like from our client app, but we were not revoking them from Frappe. So that's why we had like 400 MB of token data generated on our database. So always remember to revoke the tokens. As you can see in this post, that Frappe does not automatically delete tokens unless they are revoked. So we have to explicitly revoke tokens once we are done with them. So, so this is a code snippet. I'll go through it. So we are using our Frappe React SDK, and here how we have set up it for native use case. So in our Frappe provider, we provide the site URL. So site URL comes from the site info that we have stored in the secure store. Then we are providing it some token params. These token params, like we are using bearer token. So, and the token, we are giving it a function that is fetching the access token from our secure store. And then we give the site name. This site name is used for WebSocket. So WebSocket is required for real-time messaging, notifications and stuff. Then we are going to need some additional SWR configuration. So this configuration won't be required when we are using like Frappe provider on the web, but we have to do it here. So on the web, SWR has like reconnect on focus and reconnect on, revalidate on focus and revalidate on connect. So these two functionalities are even more important on a mobile app, because a mobile app can go out of network at any time. Like you enter a lift, and the moment you enter the lift, your network would be gone. So you are offline. And when you are out of the lift, you are suddenly online. And focus is like you always multitask on your phone, so you switch between apps, so the focus will be lost and be back. So these two revalidations are very crucial on a mobile app. So to set those up, we need some parameters we have to set up in SWR config. So init focus, so we have to give it a callback whenever the app comes back in focus. Like basically when the app state is inactive and it becomes active, it just calls the callback. So this is how it will revalidate. So here, see the app state, it is checking when the app state changes and it will call the callback. So this stuff is literally given in the SWR documentation. If you go to and look at the SWR documentation for React Native, this is basically what's given there. Then there is init reconnect. It is doing the same thing, but for network. So whenever the state changes from offline to online, it will trigger the callback. We are using the network state. So if internet is connected, it will call the callback. And finally, we have to provide some more parameters here. The provider, it is for caching purpose. So here it is just an empty map right now. But for full offline capability, we can provide here some sort of a storage that will allow us to have offline capability. Then there is visible, which is again just which returns just a Boolean value if it is the app is in focus or not. And is online, we are just assuming that it is true. This is handled just by the init reconnect handler. So Prathamesh will take forward.
Yeah. So moving on, the web and mobile disparity. So what do we mean by the web and mobile disparity, right? So when we started building the mobile app, what we did was we set up a different repository called Raven Mobile, and there is already an existing repository for Raven Web. So what used to happen is, since we are pretty new to building mobile apps, the web code was getting shipped very, very fast compared to us. And also the reason was that on the web, the things were already very much set up, and we had to build it from scratch. Also, the issue with disparity was that if any bug was being solved on the website of things, it had to be reworked again on the mobile side of things, which was causing a lot of manual effort getting doubled, also a lot of code duplication. So yeah, and apart from skill issue as well, we had a lot of disparity between the shipping speeds. So how do we tackle this? What do we do to ensure that this doesn't happen and we are smooth while shipping code? So the solution which we thought of was the monorepo approach. Now, to those of you who are wondering what is a monorepo, monorepo is basically, in very layman's term, it's a Git repository consisting of multiple projects which are not logically dependent on each other, but may be related. So imagine like a web side of things, which consists of the web implementation of the app, and a mobile side of things, which consists of the mobile side again. And if it wasn't built using React Native, you can imagine it something to be like the mobile side would be broken down into two other things, like the Android side and the iOS side differently. So this is how our app is being structured. Raven apps consist of web and mobile. And yeah, so to those of you who are wondering how to go about and know more about monorepos, we suggest reading this article by TurboRepo. I think this is the best resource which we found to know more about monorepos. They tell you in detail how to craft your own repositories and set up everything. So yeah, to those of you who want to set up monorepos later on, please go through this documentation. So that brought up the question, if we are setting up a monorepo, what part of the code can be shared between web and mobile? So as we are using React and React Native, so hooks are basically UI, most of the UI independent logic hooks, which are basically used for data fetching and stuff, can be shared since the data fetching logic is same. Again, types, the generated doc type structures, those can be shared between web and mobile. Those won't be different. And like utility functions, date conversions and stuff, those can be shared as well. So if you notice, this in all makes up 40% of the code which is written. And to share the 40% of the code between web and mobile, that itself gives us a huge plus. And that improves our shipping speed a lot. And in future, we can share UI components as well, which we'll see later on how existing companies are doing it. Currently, Raven's repository structure is similar to this. So we have the Raven repository main app. Then we have two directories. So the first is apps. Apps contains the mobile side of code and the web side of code. And packages is what is being shared across those apps. So packages consist of a lib, which again consists of hooks, providers, and utils, and there is types. So this itself makes up 40% of the code, which is being shared between web and mobile. And yeah, as I said, Blue Sky is a great example of how you can structure monorepositories and scale. So Blue Sky is a social messaging app, and it has a great monorepository structure. It also manages to share UI components, from which we'll try to take inspiration while doing it further. Yeah, so the next crucial thing while building mobile apps is Websockets. So Websockets is something that powers the real-time communication. So any messaging app that you see, be it Slack, WhatsApp, or Teams, it is mainly powered, the main communication part is through real-time socket events. So having great socket connectivity is very, very crucial for a mobile app such as ours. And so we have this hook, use active socket connection, which we are basically using to ensure that the socket is always active and connected. So what happens is when you are using the mobile app and if you switch apps or something, the app goes into background and the socket connection might break. So we have to ensure that the socket is always active so that the real-time communication goes on. So yeah, this is basically ensuring that it basically keeps polling the server whether the socket is active or not for every 2 minutes. If not, it throws an error that real-time events are not working. You should do something about it. And yeah, so as you can see, the refresh interval is 2 minutes. So it basically keeps polling and checking whether the socket is active or not. So yeah, moving on, the next big problem was the UI library dilemma. So when we are starting to build the mobile app, the big question was what should we use as a UI library? So on the web, we are using Radix, Shadcn, Abit, and Tailwind for styling. But those are not supported on the mobile side of things as of now. So we had to choose a different library for that. Then we came upon Tamaji UI. So while we were developing and building with Tamaji UI for the first 3 months, we were not getting used to the hang of it, how to style something, how to use those props and all. So we were struggling quite a bit with the configuration as well. But we were not changing things. We were not trying to use a different library all of a sudden, which was a mistake on our part. So yeah, this is a great quote by a random LLM. Your first text stack choice isn't a tattoo, it's more like a whiteboard marker. Erase, rethink, and rewrite before it's permanent. So there's nothing wrong in rewriting stuff while you still can, while you're at early stage of your development. So it's good to experiment, and if it's not working out for you, don't be afraid to rewrite and change things. So what we did was we switched from Tamaji UI to Native Wind. And then why Native Wind? Because it has a richer developer experience as it uses Tailwind styling. So we were pretty comfortable with using Tailwind on the web. So we were like, okay, this works on the mobile as well. That's pretty good. Then it was better in regards to overall theming and configuration, setting up dark and light modes, which was relatively easier compared to doing it on Tamaji UI. Then the components which were available with Native Wind were relatively more native looking, so native iOS app looking or Android app looking compared to Tamaji UI, and also they were highly modifiable. So that was a plus point. And the big challenge was the rich text editor conundrum. So to who don't know what a rich text editor is, in chat app like ours, rich text editor is like the heart of the app. So the chat input, every chat app that you see has a great chat input, like the high quality chat apps like WhatsApp, Beats, Slack, or Teams, all have a great chat input, very highly performant. And in a workplace chat messaging tool, you need things like these, like mentions, like formatting and stuff, which was not the case when we were trying to build for React Native. So on the web side of things, it was pretty sorted, but on the React Native, we were like, okay, are there any existing good rich text editors? So the general opinion in the community was, why doesn't React Native have a good rich text editor? Yeah, so also then we were thought like, can we build our own rich text editor? Then we came up upon this, like if you want to suffer for 6 months, then sure, go and make it. But yeah, we weren't able to find any good rich text editors. Even the official documentation on Expo says this, that there is no one size fits all solution rich text editor which can support everything that you need. You have to compromise somewhere. This is official documentation of Expo, by the way. So yeah, there is a lot of problems in this area. So we tried different things. We tried different libraries which were existing. We tried a few WebView libraries. We tried a few native libraries as well. So the first one we tried was a 10-tab editor and then React Native Rich editor. So mainly the problem with the WebView editors was the scrolling issue. There was a lot of, so WebView is in general lags a little since it runs through a bridge. So there is performance and UX issue definitely. You have to pay that penalty. And apart from that, there was an insane scrolling issue which we had to figure out. On the native side, we had RN text editors and React Native Live Markdown. So these editors were a little hard to configure as well. So it was difficult to adapt, as well as some of them are not correctly maintained. And in Markdown editors, the problem is mentions. So mentions are very crucial when you are building chat applications. So you have to tag someone. If it doesn't work, then the point is gone. So yeah, that was the big problem with native editors. So at the end, the solution which we came up with is, for now, just use simple text input and provide mention support. Mention is one thing that is crucial in a chat application compared to the formatting part of it. So we went ahead with this, but we also support chat rendering, right? So if you have to edit a message, then we have to support some markdown rendering. For that, we are using Expo DOM. So Expo DOM is like what Expo suggests. It's like a directive which you add to run web components inside a mobile app. So if you have heard of server-side components, you can add a directive directly to the file, and the whole file is coded in basic HTML or JSX, and that runs on your mobile app. So for editing the message, we are using Expo DOM. And yeah, moving on, what else did we use? We are using Firebase for push notifications, analytics, and performance monitoring. We are using Expo SDK, as Aditya said earlier. We are using it for mainly most of the API logics, that is camera or image picker, linking video, etc. on the mobile side of things. And we are using Legend List for the chat stream. Then we have React Native Reanimated for the native animations and stuff. And there is React Native Render HTML to showcase the entire chat stream HTML, like the formatted text, the mentions, etc. in the chat stream. And to conclude, so what did we achieve after making the native app? What have we experienced so far? We are experiencing a greater experience in viewing files and images. So the zoom, pan, all works pretty well. Now Raven can be accessed via share target. You can easily share links from other apps or anything directly into Raven. So that is a big plus point. Then the push notifications are more reliable and functional in a way that it can be now configured. You can show user avatars and stuff. You can directly message from the notifications. That can be done later. And they are more reliable as well. So overall, the haptics, interactions, animations all deliver a much greater native experience. Also, we have longer active sessions without logging out. So if you're using a PWA, it tends to get logged out after a certain duration as in what is set on the site. So mostly 24 hours for some sites. So it gets logged out, but on the native app, you won't have that problem to again log in and stuff. And offline app usage would be done as soon as it is implemented. It can be done now, which was not possible on the PWA side of things. And to share a few more bonus tips.
Yeah, so some bonus tips. So while developing, always use the development build. Do not use Expo Go. So Expo provides us like an Expo Go app on which we can run our application on top of that app, or we can make a development build. So the sandbox environment that Expo Go provides, it is like fine for trying our app for the first time, but we can't use it for development. Like we tried it for a long time when we were starting the development. And like a lot of errors that will come in an actual production build, they were like bypassed in the Expo Go. So we did not even know that a lot of things are failing when we're using Expo Go. And a lot of libraries don't even support Expo Go functionality. So a lot of native libraries, they require some kind of a actual build, and they don't support Expo Go. And a development build is more closer to a production build. Like a development build basically is a production build, but it has packaged some debugging tooling from Expo. So it has the Expo debugger and element inspector and stuff. And it runs fine. It has all the notifications auth, etc. And the development build also provides like real-time updates. So if you make any changes to the code, we can refresh the development build at the same time and it will update on our phone itself. And keep a test flight version. So test flight is basically a production build. Like it is a step further than the development build. It is a complete production build. So when we start a test flight, we can give feedback. We can actually use it on our phone and provide feedback on it. And it is like basically how it will be on a finished production app. And yeah, read through documentation. It is way better than arguing with LLMs. When we go through documentation, we can like clear the concepts about any library or something new that we are using. So going through documentation is very important because see, LLM might, like you would think that you can just ask ChatGPT how to do this, but they hallucinate a lot. They will give you completely wrong answers. They will tell you that some parameter is there, but that does not actually exist. And like even you think that is very basic. You just okay, I just want to use this library. Just implement this library here. The code the LLM might write, you will have to figure out what it has done wrong. It will take a lot of more time than if you actually just read the documentation and did it yourself. And yeah, build proper tooling before making features. So tooling is very important. Like your app structure should be proper. You should have proper common components, common functions, utilities, and stuff. And you should have this stuff like routing. The routing should be proper. So this stuff should be taken care before you start developing major features. Else you're just making something on an unstable foundation. So these are some bonus tips that we figured out on our journey. So yeah, it's time. Send a Raven. Here is a QR code. You can scan it and download our app on iOS or Android from the App Store. Thank you.